5/3. dt 2 by d rho square is going to be proportional to 1 over rho raised to 1/3. Then you take grad and then grad again. So this is going to be rho raised to 4/3, rho raised to del square d2t by d rho square is going to be 1 over rho raised to 7/3, which is going to be negligible in front of rho 1. So I'm going to neglect this term. Alright? And then I have on the side del square acting on 1 over r minus r prime, which gives me minus 4 pi delta r minus r prime. Right? So what do I have? If I substitute this, I'm going to have t2 rho at r t dt square is equal to rho 0. This term, the 0, second term is negligible. Del square v external plus 4 pi rho 1. Are you with me so far?
Sir, would rho to the power 7/3 be negligible even near origin?
No, it's a constant density.
Oh, right.
Strata is a Thomas Fermi.
Thomas.
Right? And rho 1 is a perturbation, so it's negligible. Right? So, now you see this is like forced harmonic oscillatory equation. Oh, there is a minus sign somewhere. This is the minus sign. Right? This is the direct force. This is natural. So, if V external 1 is taken to be 0, right? Then the natural solution gives natural frequency. Agreed? And what do I have? In that case, I have rho double dot, right? Rho double dot plus 4 pi rho 0, rho 1 equals 0. Right? And this gives you natural frequency omega plasma square equals 4 pi rho 0. So this fluid situation is giving you the derived semi-quantum mechanically using Thomas Fermi theory. What it is giving you is, if I leave the system and if I disturb it a bit, this natural frequency is what it is, which is nothing but the plasma frequency. Is that okay? You can do more. This is for the infinite system.
So this is just the cross check, right?
Huh?
This is just a cross check.
No.
We are getting a plasma frequency.
No. I'm deriving it from quantum mechanical equation, TDDFT equation.
So we have said external potential to be 0, V1 external.
Yeah, so whatever you get, it's unforced harmonic oscillator. So whatever frequency I'm going to get is going to be the natural frequency. That's the plasma frequency. Okay, you can do more. If you take some other system, if rho unperturbed is going to be taken to be rho naught r. For example, I can take an atom and solve the equation. Give me frequency of collective oscillation. I'm giving you a way of doing it. I'm giving you a way of calculating frequency. Now, I had also written, okay? So for example, or I'll take a cluster where the density goes like this. And plug it in here, somehow then the computer solve it, right? And with all the proper grad and everything, I would take this rho naught out and all that because rho naught did not depend on R. If it depends on R, then you'll have a more complicated equation. Nonetheless, it will give you the collective oscillations. Okay, so it gives you the acceleration frequency. Collective oscillation is one of the acceleration frequencies. Now, remember I had written minus d phi over dt is equal to delta E delta rho, right? I can write this as E plus d phi by dt times rho del by delta rho equals 0. Right? And this together, and Abhishek, this answers your question, earlier question. This together tells me that the time average E rho plus integration, what is it? d phi by dt. And this E rho is that dt E rho. Huh? This has that integration half del phi square rho also. ETD, so ETD rho time average is the quasi energy in periodic TDDFT, and I can minimize it and get my answers. So it gives me a way of doing variation calculation. Any questions so far? All I'm motivating is, I'm giving you a purely quantum mechanical treatment in terms of density and current, through which I know how to calculate collective excitation frequencies. Is that okay? Now, obviously, if you're doing variation calculation, you'll have to assume a form for phi, you have to assume a form for rho, and then do the calculations. For example, I can give you an example. Suppose we want to do linear response, right? So for linear response, I'll calculate rho 1 and phi 1, phi 0 is invisible. R the relevant quantity. And the functional to be minimized is E sigma rho 1. This is a regular known thing in variation perturbation theory, that if you want to do the perturbation for the first order, you minimize the second order energy. And first order gives you energy all the way up to third order. And this is 2n plus 1 theorem and the variation nature of the 2n term. So right from here you can write what is going to be E2? E2 is going to be, let's write it, and it's going to be only in terms of row 1. Okay? So E2 is going to be the second order term, time average, one half delta 2 T delta rho R prime. Alright, calculated at rho 0 now R for some other density. Rho 1 RT, rho 1